So whatever's going to get recorded will go onto the YouTube video later. Cool. So what I was saying before everyone arrived is that we're going to focus basically today's lesson on this on the left-hand side, the core work. So use symbols of the elements and write the formula of simple compounds, deduce formula, construct and use word equations, and interpret and balance simple symbol equations. And I don't have notes for this, so I'm going to literally be making the notes as we go along. And then I'm going to upload the notes onto Google Classroom afterwards. So we're literally making the notes as we go along. Just give me a second. Here we go. Cool. So what you should see is a white page. It's a bit laggy, but what you should see is basically I'm sharing my iPad screen with you, and then you'll see here that I can write on the screen, and that's what you're going to be seeing. Hopefully, if it doesn't lag too much. Ooh, it's lagging a lot. Can anybody see the purple thing that I just wrote there? Oh, there it comes.
Yes.
It's literally just coming now.
Yes.
It says my internet connection is unstable. Okay, there it is. Eventually it came. So don't worry. If you miss it now, it'll come on the YouTube video again later. So all this will be there. Oh my goodness, it's so laggy. Wow. Oh no, this is going to be useless. This is not going to work at all. Oh goodness. Okay. So you're probably going to see something appear and disappear like in an instant. Yeah, I drew that like 30 seconds ago. Okay, so let's yeah, talk to me.
Would it maybe work better if you open like a Word document and you write something?
I think that's going to be easier. So I'll see what I can do there.
I don't know.
I think that's a good idea for now. So for now, it's probably going to be an easy idea. I just think the internet is so bad at the moment that I don't think it's going to work either way. But let's have a look. I think that's a good idea. Use this. The problem with the Word document is that I can't draw as nicely, but I'll see what I can do. Screen share, and now I'm going to share the Word document. There. So if I start typing, can you see those letters coming up now in front of you?
Yes.
There's no lag, that literally just comes up straight in front of you. So what the syllabus says is that you have to use the symbols of elements and write the formula of simple compounds. So if, for example, if I write H2O as a compound, I'm basically saying that it's 2 H atoms bonded to 1 oxygen atom. So the 2 and the 1 have meaning in terms of the equation. The 2 and the H are linked over there, and then the 1 and the O are linked because there's an imaginary 1 at the end there. So I'm not saying this is easy or this is simple, but this is basically a revision of what we've already been seeing the whole time in terms of chemicals and symbols and formulas and stuff. Also, if you look at something like sulfuric acid, H2SO4, you can basically say from the formula, can you work out how many hydrogen atoms, how many oxygen atoms, how many atoms. So anybody just out quickly, let me get the participants and then I'll pick on someone. So just somebody off the top of your head, let's say Mia, tell me how many hydrogens, how many sulfurs, and how many oxygens. Okay, Mia, I don't think has a microphone. Gotcha, since you've got a microphone, you can go for it.
It will be 2 hydrogen atoms.
Correct.
I think it's either, I'm not sure if it's either 1 sulfur atom
Correct. You're 100% correct.
and
then
4 oxygen.
4 oxygens, correct. So it's a bit difficult now. So if I space these out a bit, then I can draw the arrows in, and then you can see where those numbers come from. So the 2H comes from that over there. The S comes from the imaginary 1 that doesn't appear there. And then the O comes from that over there. Cool. So that's basically saying, can you see a structural formula, or can you take the number of atoms and construct a formula? So now we can do it the other way around. And I can say construct a formula that has 2H atoms and 6 oxygen, no, sorry, carbon atoms and 6 hydrogen atoms. And then the question is, can you write the chemical formula for that? So what's the symbol, what's the chemical formula for that in terms of carbons and hydrogens? And this shouldn't be difficult. This should be pretty straightforward. You don't have to overthink this. So anybody besides Dr. Laura?
C2H6.
100%. So that's literally what the syllabus is basically trying to tell you, is that you need to be able to look at a chemical formula and tell yourself that you know what it means in terms of the number of atoms of everything present. So I'll see if I can quickly share that with you instead. There we go. So share that. And it's literally just that tiny little point over there. Let's put a box around it. Use the symbols of the elements and write the formula of simple compounds. And then deduce the formula of a simple compound from the relative numbers of ions present. And then what you also need to be able to do is you need to be able to do representations. So if I give you like a structure, for example, I'll Google one quickly now, and then I'll just copy and paste it in. So
Mr. James,
hello.
when do you know when to put the like the numbers? When do you know when to put it like big in front of the letter or small next to it?
Excellent question. I know exactly what you're saying. So for now, like for what we're busy doing, never in front, only always as little numbers in the inside. Yeah, the big numbers you'll see will come later when we talk about balancing chemical equations. Then we start putting numbers in front. Cool.
Okay.
Now,
thank you, sir.
Yeah, very good question. So for now, only small numbers at the bottom right-hand corner of every symbol. Okay, so the question here is, can you write the formula based on the structure? So what is the formula of this? Just in terms of C's, H's, and O's. So you have to give it to me in terms of C, H's, and O's. So how many C's, how many H's, and how many O's? Somebody that hasn't answered, Nina, Tia, Tandy.
Sir, I can't see the question.
That's probably correct because I'm sharing the wrong screen. So let us share the correct screen and then you'll see it. Sorry, I'm so used to using the iPad now, I've forgotten how to use the computer. There you go. Can you see that now?
Yes, sir.
There you go. So that's the question there. So based on that, can you write the chemical formula?
Would it be C2?
Correct.
H6, so hydrogen 6, and
Correct.
just oxygen alone.
And just one oxygen, correct. So you can put an imaginary one there if you want to, but it's not necessary. So that little one there means, it's like saying 1x in maths. 1x in math is just that. And that there would be the chemical formula. And again, you've kind of seen this already because we talked about this when we did organic chemistry. So I'll quickly Google another one and find a little bit more complicated one. Let me think of a simple. And again, you probably don't need to know the names of these things. You would just be asked to write the chemical formula based on the structure. So here's another example. There we go. And I'll make that a little bit bigger so you can see it. Oopsie, grab onto it and make it bigger. So anybody that hasn't answered yet, who would like to give this one a go? Cool, C's, H's, and O's. Nina, would you like to give it a go? Tandy, yes, I hear you, Tandy.
C3, H6, and O2.
Correct, H6 and O2, 100%. So you counted the carbons 1, 2, 3, you counted the hydrogens 1, 2, 3, 4, 5, 6, and you counted the oxygens 2. And again, you probably don't need to know this molecule, but you do need to be able to identify its, don't need this specific. In other words, you don't have to give it a name, you don't have to tell me where it's useful for, but you have to be able to give me its chemical structure. Okay, so let me just think of one more quickly. Wait, let me get a one that's a little bit more tricky. There we go, that's a nice one. So they could give you something like this that looks weird and wonderful and confusing, but you don't need to get caught up in the complexity of the molecule because all you need to do is count the carbons, hydrogens, and oxygens. Now, when it says H2 on the molecule, that's telling you that that position already has 2 H's, so you have to count it as 2. Who would like to try this one? Tia? I think you tried one already. Sorry, no, Tia's done one. Inesh or Laura?
Sir,
Yeah.
would it be C6,
Gotcha.
H12,
2, 4, 6, 8, 10, 12. Yes.
and just the one oxygen?
Just the one oxygen, correct. That's 100%. And again, you don't ever need to know the specific molecule. You don't need to know what it's used for. You don't know where. It's not anywhere in the syllabus, but given the structure, you have to be able to show me, you have to be able to write down the chemical formula. So when you go back to the syllabus and you read what the syllabus says, the syllabus is basically telling you from your deduce the formula of a simple compound from a model or diagrammatic representation. And that's what we basically did from a diagrammatic representation, which would be that.
So
Yeah.
I have a question. If
Of
they
course.
give you an unfamiliar molecule or
Sure.
something with like iron and all these different elements,
Sure.
how do you know which one you write first? Like
Very good question. It'll probably not be in a structured question. It'll probably be in a multiple choice question. So these kinds of questions 9 out of 10 times come up in a multiple choice question. But if it does come up in a normal question, you can write it in whatever order you want.
Okay, so it doesn't have an effect on the final answer.
Correct, because we don't have to learn what's the word I'm looking for. We don't have to learn the correct order. We just have to be able to list the number of each element in the compound. So let me look for one that might be tricky. Let's say, find a nice one. Let me just make sure that I get it in terms of C's and H's. No, let's find this one here. Like 1,000 molecules on the top of my head, but I just can't think of one that I can show you quickly. There we go. Okay, so you would never have seen this molecule before, but it could come up. So here's one here that has a bromine atom. Who wants to give this one a go? And in this case, let's just put the bromine at the end because we're used to the C's, H's, and O's, and the bromine is kind of like the add-on. Cool, so you could just number this one. How many carbons? Anybody?
5.
Cool, 5 is good. How many hydrogens?
11.
11. And then how many bromine? How many? Oh, there's no oxygens. Sorry, there's no oxygens. And then bromine would be 1. But that 1 is unnecessary, so we can get rid of that. So if you wrote it as BR, oopsie, hang on. If you wrote it as BRC5H11, that would be perfectly acceptable. There's nothing wrong with that. Well, because the number of atoms hasn't changed, you've just listed them in a different order. It's a very good question. It doesn't make a difference, but very often it'll be in a multiple choice question, and all you have to do is just pick A, B, C, or D. Any questions so far?
No, sir.
No, good, good, good. I'm going to see if I can get the iPad to work because I need to start drawing now. So if it does work, good. If it doesn't work, then I'll go back to the computer. Maybe it's sped up now a little bit. Have a look there. There we go. That's better. Now it's coming up as I speak. Yeah, perfect. Much better. Okay, so now we're going to start with balancing chemical equations. Balancing chemical equations can be tricky, but it can also be very straightforward if you don't overthink it. And very often with your type of questions, they're not going to give you difficult ones. They're going to give you simple examples. So I often give students very complicated examples to practice with, but often in the exam or the test, the questions are very simple. So I'll just make one up here. If I take, for example, nitrogen, and I react it with hydrogen, I'm going to get ammonia NH3. So you don't need to know the specific reaction, but it could be an example that they could say, here's an equation, and now you need to balance it. So a balancing literally means we're counting atoms with what we're starting with, and we're saying, what can we turn those atoms into? So remember that there always has to be bond breaking and bond forming. So we have to break apart everything on this side, and we have to form everything on this side. When you think back to endo and exo. So what I like to do is I like to draw these things as pictures, and I like to give them a little bit of like a visualization. So instead of drawing N2, what I'll draw is I'll draw an N2 molecule like that, and I'll draw an H2 molecule, let's say like that. And then NH3 is a little bit tricky because I've got to use both colors. So I'm going to have the 3 hydrogens, and I have to have the 1 nitrogen. There we go. Cool. So everyone happy with that so far? I've basically taken the nitrogen and I've drawn it as a ball and stick model like that. I've taken the hydrogen and I've drawn it like that. And I've taken the ammonia and I've drawn it like that. Cool. Just looking at that without overthinking it, what problem do you see in terms of just the number of oranges and the number of greens? Without overthinking it, what problem do you see?
It's not equal.
It's not equal. So maybe you've done balancing equations before, so you know this. But if you've never done balancing equations before, you might look at it and you might say, hang on a second. There's 2 orange dotty thingies on this side, and there's only 1 orange dotty thingy on that side. And there's 2 of these green thingies on this side, and there's 3 of them on that side. And you have to sort of ask yourself, well, how can I take everything over here and turn it into that if what I started with and what I end with is different? So how are we going to solve this problem? What do we need to change? Don't think about it in terms of balancing equations. We're not thinking about it in terms of formal structure, but what would you like to have happen in order for this to work nicely?
We need another hydrogen.
So you probably need another hydrogen. So we're gonna solve the hydrogen problem by adding another one of these. And then we can keep a record of our count, and we can say we had 2, we added another 2. So at the moment we have 4 H's, but does that solve our problem?
No.
Yeah, so that hasn't quite solved the problem yet. And this is the problem with balancing equations. It's literally like taking a seesaw and constantly trying to balance the seesaw. And every time you put something on the left, something on the right unbalances itself. Okay, so what can we add to the right-hand side to try and help balance out the hydrogens now? So what can I add on the form side?
We add another 3.
Correct. But now the problem is they don't come on their own. They always come with a nitrogen. So I have to buy it as it's a packet deal. So if I get 3 hydrogens, I also have to get a nitrogen. So is that starting to look a little bit better now? Yeah, so that's starting to look a bit better. So what problem have I solved in terms of the colors? Which problem have I solved in terms of the, which have I solved?
Nitrogen.
Correct. So you can see there's 2 over there. And then if I count the number of hydrogens, I've got 1, 2, 3, 4, 5, 6. Here I have 1, 2, 3, 4. So what's the final step to solve the problem?
We add another hydrogen.
Correct. And remember, they come in pairs, so I have to add another whole one of that. That's 1 and that's 2. And then I can add an extra, that's 5 and that's 6. And now it makes sense because I've got 2 oranges on the left, I've got 2 oranges on the right, I've got 3 greens, 6 greens on the left, and I've got 6 greens on the right. Now what I need to do is I need to write this into my balanced chemical equation. So I start with the basic formula again, and then NH3. And then what I need to do is I need to add the numbers. So how many of everything do I have? So of these, of the nitrogens, I've got how many in total, not in terms of the atoms, but in terms of the molecules, how many total molecules do I have? So 2 atoms are combined, they form 1 molecule. How many molecules does this count as?
1.
Yeah, that's 1 molecule. So I can take that over there and I can say that I have 1 molecule of nitrogen. Cool, then I have to count all my hydrogens. So I've got to count all of these. And not the atoms, there's 6 atoms, that's correct. But how many molecules do I have?
3.
Correct, it's 3 molecules. So I need to write a 3 over there. And then on the far right-hand side, I have to count the total number of molecules here. That's 2, correct, and that's a 2. And then Mia, are you still there? I don't see the participants. Mia, are you still around?
Yes, sir.
Yes. Do you see now what the big 2 and this big 3 and the big 1 in the front mean now?
Yes, sir.
Correct. So those big numbers that come in front represent the number of each molecule. So it doesn't tell you the number of atoms inside the molecule. It tells you how many of each molecule do you have. So how many nitrogen molecules, how many hydrogen molecules, and how many ammonium molecules. Remember that molecules are bonded. Atoms are separate, molecules are bonded. Cool. Does that make sense? Do I need to clarify anything? Would anyone like to ask any questions?
No, sir.
No, you good? Inesh, Nora, you good?
Yes, sir.
Good, good. And Tandy, you good? Tandy's good. Okay. We're on the same Wi-Fi, so if I'm lagging, she's lagging. Cool. So what I'll do is I'll give you a take a little break. Let's make it 5 minutes, 10 minutes. Let's take a 7-minute break. So be back at 12:37. Cool. Everyone happy with that?
Yes, sir.
Yeah, good, good. So guys, I forgot to mention this before the lesson. It's probably a good time to tell you now. It's a good thing to have a pen and paper out with you because I'm going to give you questions now and I'm not going to give you the answer immediately. So for the next lesson, just have a pen and paper with you so that you can write stuff down. Cool. And then be back in about seven minutes.